We are Resilient Road. We are working on a solution to help national highways become more climate resilient and know where extreme weather events cause delays.
Getting the data. The government publishes yearly data on road delays. However, the format of this changed in 2015. The way the published data was aggregated meant that it couldn't be broken down by road and month. Some of the historic data from 2011 to 2015 was published in a way that this was possible. However, it was missing ONS information. In theory, you could go through and add this as you had the road names. However, we did not have the time to fully explore this option. In Python, we were able to pull out a unique number for each road. Ideally, we'll be able to use that and map it to the ONS information so it can work better with the GIS. We also did a lot of work in Python getting the weather data into a usable table. The way some of the station names were set up did not align, so we worked on a way to check and fix this based off of similar values.
So the first page of the Power BI report depicts the information on the delays of the strategic road network due to the weather disruptions. There are 6 datasets that have been used in the project to forecast the delays. The data was cleaned and manipulated according to the requirement using Python. The data is then loaded into the Power BI as an Excel spreadsheet, and various transformations are performed in the Power Query to adjust according to the requirements. And the first page shows the overview of weather conditions and its impacts on the delays in the road network. The page also tells us about the various climatic conditions and its impact on the delays caused. For example, this visual shows the maximum rain recorded by the month, and it also shows top 10 stations which has highest temperature recorded and also the minimum temperature recorded based on the season wise. And the filter is also in place regarding the region name, so you can filter it based on the regions and see the year and the season where the temperature has fallen down or fallen up, and the delays in the strategic roadmap. The second page shows the delays of the year 2019, and we have included various maps in order to show based on the rainfall and sunshine and the delays that caused based on each weather condition. Again, the filter is in place for the regions, and once we choose the region, we can see the overall delays that's caused. And the filter for the year is in place in the filtering pane. The second page shows the delays due to the weather conditions of 2020, and again the filter is in place. It's a similar visuals that has been used in the second page, and the filters are also placed, and the color coding is in for the rain and for the sunshine, which shows the differences of the values. For example, if the highest rainfall is recorded, it is color coded as dark in blue for the rainfall and dark in orange for the sunshine. And the disruptions in the road delay shows the red lines, which actually gives you an idea of how the road gets delayed due to the weather conditions. To complete the prediction of future delays, we require a set of informations on the road codes, which is missing to create that model to strategically prove the predictive analysis on the delays in the road network. Hence, we have used the current data to only analyze the past weather conditions. But if we have the future available information, we would be able to predict the analysis and show the predictive model working for the delays.
So in this part of the Power BI analysis, we try to combine the weather forecast information and the delay information that we got from highway website. So the user can choose the part of the road from this filter, and then they can show the delay data, which is the output, and the weather informations like sun, rain, minimum, maximum temperature. So if we give an example about it, in 2012 we have an increase in the delay, and obviously we have an increase in rain information as well. So we can say that might be the reason of the delay on the highways. But similarly, there is another increase in 2014 that's even more than 2012, but it doesn't affect the delay too much, which we can say that government solved the issues in the highways. So this kind of analysis can be done with a comprehensive data, but we just want to show a possible solutions with that page in Power BI.
As a result of the quality, we had to use some assumptions in our analysis to link weather data and highway delay data. It took a lot of time to clean the data and come up with a suitable approach. Time was also tight, so we had to omit data that could have been utilised if we had longer. We also tried to contact the Department of Transport for clarity on some of their published data, specifically the unique codes we were able to extract from their historical publications, but we did not hear back by the time of recording. As a result of not being able to use it all, we could not do any predictive analysis because the fully mapped sample was too small to draw any reasonable conclusions, and we would have overtrained the model. We have utilised some of Power BI's built-in mapping tools, including their free version of ArcGIS. The published road delay data was already summarised and it was not possible to break it down. However, the government had published it as an interactive map for 2019, 2020 and 2021. It had also been added to ArcGIS as a layer along with the strategic road network. Our dashboard has been designed to be very visual and highlight the strategic road network, as well as impact of rain and sun and other weather events. The free version is very limited and only allows one layer and no changing of the base map. If we had access to the full license, we could overlay our weather data on the published delayed data. We could also utilize other data sources such as the Open Rail map. Extreme weather will impact the strategic road network, but it will also impact public transport use. If flooding, for instance, results in trains not being able to run, you would expect to see an increase in road users. ArcGIS also includes demographic information. We'd be able to identify lower income areas and see whether they are disproportionately impacted by extreme weather and delays on the strategic road network. This will also better help the Department for Transport and National Highways target where they need to invest.